I'm going to talk about improper error handling, but I want to touch on this OWASP top 10 definition to begin with, and clearly it is security misconfiguration. Now this is a fairly broad topic, it encompasses many different things, but one of those things is the leaking of internal error messages. So what we're going to see in this clip is how an internal error message can be leaked, and then when combined with another risk, how it can be exploited to expose sensitive information. Now by OWASP's definition here, the exploitability of security misconfiguration is easy, and you're going to see just how easy it is in a moment. They've also classed detectability as easy, and you've probably seen many times before where you've been on a web application, clicked a button, and then suddenly seen an internal exception due to the fact that the application has implemented improper error handling. So in terms of how easy it is to detect, you can just stumble across it by accident when using an application exactly as it was intended to be used. So let's move on and take a look at just how damaging it can be when errors are improperly handled. So it's back to our sample vulnerable web application again. And I'm going to scroll down a little bit, and then I'm going to click on View NISNs. Now we've got one NISN here, we've got the GTR, and that's fine. But what I'm really interested in is the URL. Now this URL appears to have a combination of a very semantic-based routing convention, where we can see that we're looking at make number 1, and it has a query string as well. As we learned very early on in the course, both of these components of the URL are untrusted data. Now that means we can modify them as an attacker and potentially get the application to do unusual things. Here's what I want to do. I want to go and change the make from number 1 to number 100. Let's see what that does. And here we see an internal exception. And this exception has bubbled up, or in other words, it has appeared in the browser rather than just being encapsulated on the server. Now the exception we're seeing here is sequence contains no elements. So this alone is actually giving us a little bit of information about what's going on in the underlying system. And if we were to speculate, we'd say that make 100 doesn't exist. And somewhere in the code, it's taking that piece of untrusted data, going to the database, not getting a result, and then the code is unable to handle the fact that the sequence doesn't contain an element for make 100. Now in this particular exception here, we've also got a stack trace. So this is detailed internal implementation data about exactly what is going on. This allows us to start building a picture of how this application is behaving internally. Further to that, if we scroll down to the end of the page, we'll see that we've got framework version information. So there's the .NET framework version, and there is the ASP.NET version. So that's pretty detailed information. That would be enough to reproduce the sort of exercise we did earlier on in the course with Drupal, where we identified a vulnerable Drupal version, went to Shodan, searched for it, and then located every site that might be at risk of that really serious SQL injection flaw. So this is another little piece of information leakage which can be valuable to an attacker. But I want to take this a step further. We know that this page is improperly handling exceptions, and it would also be fair to speculate that a page like this is probably hitting an underlying database. So in this case, there is probably a table of makes. And when we hit this page and we hit it with make 100, it's probably going to the database and attempting to get a record. Now I'd like to use a very small SQL injection attack here. Let me paste the SQL injection attack into the URL. Now take a quick look at what's happening here. It's the same path, albeit with make number 1, which we know is successfully loaded, and the order by query string has now got a SQL statement after it. Select top 1 password times 1 from user profile. Now again, there's an entire course dedicated to SQL injection in the Ethical Hackers series, so I'm not going to explain everything that's going on here again. What I will say though, is that this query is going to execute in the database, and it's going to try and multiply the first password in the user profile by 1. Let's see what happens when this runs in conjunction with improper error handling on this page. We get an error message which is now enormously useful. Conversion failed when converting the nvarchar value password with a 0 to data type int. This is an internal password from the user profile table in the database, and we are now seeing it in the user interface. So what we've just done is exploited the fact that this application has implemented improper error handling, and we've then caused an internal exception in the database. So the message that I just read out is an actual error message from the database itself, which has then been returned to the web application and then bubbled up into the user interface. So this is how these attacks chain together. Improper error handling in conjunction with the SQL injection risk means that we can get passwords out of the database. Now this is just one very, very small part of SQL injection. And again, I do encourage you to go and watch that course in order to better understand it. But it's a perfect illustration of just how devastating improper error handling can be. Let's now move on and look at something quite different, and that's insecure cryptographic storage.